So I now start with presenting chapter 5, and that will be the beginning of the behavioral part of this course. In this chapter, the first behavioral theory will be presented to you. In the presentation, the organization of sections will be a bit different than the book. Writing and speaking sometimes better are done differently. So the sections that I use here do not exactly correspond with the sections in the book, but so be it. Anyway, I'm going to introduce the first, more or less the first sound theory that was invented, and also the prevailing theory today. It's part of prospect theory, and it's a part of the rank-dependent utility theory that Quiggin invented in the end of the 1970s, early 1980s. That is a crucial part of prospect theory. I could present the formula in 3 minutes to you, just tell you, memorize it, go home and do your homework, and so be it. But I don't want to do that. I want to take almost a whole hour to explain the formula to you, how it was invented, so that you get a feeling what it means. And in particular, I often say the behavioral approach turns economics into mathematical psychology. I want you to feel that in this course, and we want to go a bit deep in this course, so that you see how this formula captures psychological process going on in human beings, how it captured that in a mathematical model. That's a typical thing of behavioral approach, psychological realism, but also good firm models that capture it. And that's what we're going to do now. And I start repeating a few things you already know to prepare the right way for the novelty to come. We have already seen that the simplest way to evaluate risky prospect expected value, Christian Huygens wrote about it, was an important insight in those days. Here is the expected value formula. We already know it's violated risk aversion. People often rather have the expected value than the lottery. We need something more general. Daniel Benoit said, let us do expected utility, that's better. So we have seen it before, the utility of money determines risk attitude. And indeed, we have a theorem, risk aversion, if and only if utility is concave. In expected utility, the utility function completely captures the risk attitude. So everything about risk attitude can be related, studied through properties of utility. You see a nice result. And we have already seen, that's concave utility, we have already seen index of how risk averse people are, and an alternative index for positive money amounts is if you multiply it by that money, that's the relative index of risk aversion. It can also be useful, both are useful in different circumstances. Anyway, there is an intuitive problem here, and I wonder if you can, so with that claim, I wonder if you can travel back in time in your memory. Do you remember when you first saw this result? Risk aversion, if and only if utility is concave. There's something weird about it, and you feel, it feels strange, you know? It's because risk aversion is probabilities, uncertainties, but utility of money is how much happiness money gives, how much warmth in your heart, so to say, you get if you get money. You have the feeling those are different parts of your psychological identity. How can they be equivalent to each other? So psychologists from the beginning did not like this result and said that this was psychologically implausible. Economists are less open to such arguments of psychological processes. Economists say we have real preference, we have proved mathematically that this is true, end of discussion. But psychologists insisted, continued, and I think here the field really benefited from the psychological insights that there is something weird about it. But the thing is, the utility is determined by what is it money, or is it the amount of wine, or hours listening to music. All of those outcomes have different utility functions. So would it be that your risk attitude is completely determined by the outcomes that you face and have nothing to do with probabilities? It feels weird. For instance, there can be non-quantitative outcomes. Then you cannot even define risk aversion, an expected value. So there are reasons already to doubt about whether this is good modeling. There was a psychologist, Lola Lopez. She eloquently wrote about these things. It was already in the 1980s. She wrote about it, but already in the 1950s, 1940s, from the beginning, in the 1940s, Phenomenal Morgenstern introduced expected utility. From the beginning, psychologists protested. For instance, Lola Lopez once she wrote, risk attitude is more than the psychophysics of money. Psychophysics is a field in psychology that studies how physical stimuli generate feelings in us. If a drop of water comes on our skin, how much coldness do we feel? If some sound, how much loudness do we hear? Those kind of things. And then money, if we get the money amount, how much warmth do we feel in our heart? That is, so to say, what utility is, psychophysics of money. She immediately said, there is more to it. It can't be just that. And well, there have been other criticism of expected utility already, for instance, centuries before. Here is French, we will not read it, but there's a French text, and he already said, well, it's weird what you're doing there, the linear treatment of probability, why would that be? And you can read it at home, we will not read it here if you like to read French language. But the idea has always been around. And here's a citation by Tversky, and this is a very good text that really captures the ideas, as always with Tversky. So really you should read it, but stop the video, let me not read it loud, stop the video and read the whole text, and then resume listening to this recording. Besides this intuitive a priori problem that you can feel immediately if you see the formula, there have also been empirical problems, many, and you have already heard about it. The Allais paradox, well, you probably heard about it. It will be part of today homework to study it. There's an Ellsberg paradox. I did not explain it to you yet. It will be near the end of the course that we will discuss it. That was another paradox showing that expected utility is really violated empirically in strong systematic manners. And from the beginning, what we already saw a bit in our experiment, that we have, if we do utility measurement different ways, we get inconsistencies. Those are also violations of expected utility. This was already known in the early 1980s, that that's another problem. So these were all kind of reasons that people, also Rabin at 2000 was a bit later after invention, but this is also a very good paradox showing that there are all kind of problems with expected utility. So there were many reasons for people to understand we want to develop theories more general than expected utility. We should really do that for empirical work, for all the reasons that I mentioned, and some more that I didn't say. So people develop new intuitions, but that I will explain in the next recording.